Habari zenu, karibuni katika session hii. Hapa ni Elimu Kiganjani, na katika session hii tutaendelea na solving, ambapo solving hii ni mtihani ambao umefanyika mkoa wa Kilimanjaro mwaka 2022, mtihani wa hesabu kidato cha pili. Ukirefer back kwenye session zilizopita, tulikuwa tuna solve maswali kwenye mtihani huu, swali la kwanza mpaka swali la 7, na session hii tutasolve maswali mawili, kwa maana kwamba swali la 8 na swali la 9. Sasa swali la 8 ni hili kwamba in the figure below EH equals to GH, EH equals to GH, and both triangle EHF and the triangle GHF are right angled triangles, as we have seen here actually, that there is a right angle there. Prove that the triangle EHF and the triangle GHF are congruent triangles. So here we go. We are going to start. We'll be saying proof. So I'll be saying that in triangle EHF and triangle GHF, if you consider those two triangles, now we are going to check all sides, which will give us a way to go to proving that those two triangles are congruent. And so in these two triangles, we have seen that EH in the first triangle, EH equals to HG, and this is given detail. It is given information already. You go to angle EHF. Angle EHF is equal to angle H equals to angle H, equals to angle GHF. So this is actually given. That is 90 degrees, dear students and dear viewers. And then you have seen that FH is common side. FH, it is common side. So by using this three detail, we can conclude that triangle EHF is congruent to triangle FGHF. I could say GHF. And what is the theorem here? It is actually side angle side. It is by side angle side, dear students. So we have already proved that these two triangles are congruent by side angle side congruent theorem. We are going to jump to question number 8b. In triangle PQR, if triangle PQR is similar to triangle LMN, so we are going to use two triangles here. So this is the first triangle, and we are going to have the second triangle. Okay, this is our second triangle, and so this is PQR, and this is LMN. Make sure the naming fall exactly the same given order. So we are given PR is 20 centimeter. PR is 20 centimeter and NL is 10 centimeter. NM is 12 centimeter and LM is 9 centimeter. Here is 9 centimeter. Find the length of other sides of triangle PQR. So we're supposed to find the other side of triangle PQR. So by using similarity theorem, we know that the ratio of corresponding sides are equal. And in this case, we're going to say that PR over LN, this is equal to PQ over LM. So putting the details, we see that PR is 20 centimeter divided by LN, that is 10 centimeter. This is equal to PQ. We are looking for PQ over LM, which is 9 centimeter. Upon simplification, you can see here is 2 and there is 1. So actually PQ will be 2 times 9, which is 18 centimeter. So that is PQ. We are looking also for RQ. We're going to use actually the same ratio, PR over LN equals to QR over MN. So that you'll be having 20 centimeter over 10 centimeter. This is equal to QR. So what is QR? Is unknown side, QR over 12 centimeter. And eventually we have QR, dear students. Upon simplification, here you have 2 and there you have 1. So QR is 24 centimeter. So we were looking for the length of other side of triangle PQR, and we have already found the sides that PQ is 18 centimeter and QR is 24 centimeter. We jump now to question number 9. I just want to remind you that these questions have to be questions actually which fit the format of the current Form 2 National Assessment Test Mathematics. So you can compare the way the exam actually appears in national exams, and you're going to see actually similar questions with a similar format coming in the national exams. So we are going to jump to question number 9, and this is going to be the last question in our session, in our today's session, dear students. And here is the solution. In a right-angled triangle, tan theta is, so we are given tan theta is 5 over 12. Okay, find the value of sine theta and 2 cosine theta. So first of all, we are going to sketch a right-angled triangle in a very rough way. An apology. Okay, I'm not going to be satisfied with this. So we're going to have a very rough right-angled triangle. So this is our right-angled triangle. You have 90 degree, and this is angle theta. Tan theta is opposite. Just remember that tan theta is opposite of our adjacent side. So tan theta opposite being 5 over adjacent side 12. We'll be looking for this side here, C. So C square is 12 square plus 5 square. by using Pythagorean theorem. I could say that by using Pythagorean theorem. So by Pythagorean theorem, we get c square equals to 169. So c will be actually square root of 169, which is 13 centimeter. Now we are looking for, we assume that actually theta is acute angle, so that we are not going to consider negative part of this expression here. Well, now coming to sine theta. By definition of sine theta is opposite side of a hypotenuse side. So opposite is 5/13. That is Roman 1. Coming to Roman 2, 2 cosine theta. This is actually same as 2 multiplied by opposite side of a adjacent side of a hypotenuse side. So that you have 2 times adjacent side, it is 12/13. Eventually 2 cosine theta, we get 24/13, dear students. So that is question number 9A. Jumping to the last question of our today's session, question number 9B. A ladder 15-meter long rests against a vertical wall such that the foot of the ladder is 60 meters from the wall of horizontal floor. Find the angle that the ladder makes with the wall. And Roman 2, you're supposed to find the height above the floor at the top where the ladder touches the wall. So we have a ladder 15-meter long rests against a vertical wall such that the foot of the ladder. So if we have to sketch, so this is our vertical wall. An apology for rough sketching. So this is our vertical wall. And we were informed that a ladder actually now rests against the wall. Okay. So this is our ladder. And this ladder is 15-meter long, dear students. Such that the foot of the ladder, here is the foot of the ladder, is actually how many meters? 6 meters from the wall. So this distance here to the wall is 6 meters. Find the angle that the ladder makes with the wall. We are talking of this angle here, theta. We are going to use cosine. Cosine theta equals to adjacent side is adjacent side of a hypotenuse side. So adjacent side is 6 meters over 15 meters. Cosine theta. Eventually, when you divide cosine theta, you'll be getting 60 divided by 15, which is 0.4. So you're going to read it from the table, mathematical table. Theta is cos inverse of 0.4. And when you find cos inverse, you get 66.42 degrees. So that is the angle. And you're supposed to find the height above the floor. So height here is how much? You can use actually Pythagorean theorem, or you can use definition of tangent. Anyhow, of course, I would prefer to use Pythagorean theorem, so that actually by Pythagorean theorem, By Pythagoras theorem, 6 square plus h square equals to 15 square. So you have h square equals now 15 square minus 6 square. You put the difference. Putting the difference, you have 15 square minus 6 square. Eventually you get 189. H square is 189, and the square root of 189, so h will be 13.75 meters. So that is solution for Roman 2. This is for Roman 1. The height above the floor at the point where the ladder touches the wall. So you're going to conclude that the height is 13.7 meters, dear students. So we managed to solve 2 questions. I just want to remind you again that if it is your first time to be here, consider subscribing to the channel so that you're going to be updated on other coming content. I wish you all the best in your mathematics learning journey. See you in the next video.